Mega earthquakes. The Earth is constantly shifting beneath our feet, but most of the time we don't notice it. The largest earthquakes, however, are so powerful that they alter the landscape, trigger giant waves, and sometimes even change the length of a day. When we talk about the world's largest earthquakes, we are referring to events that release hundreds of times more energy than typical quakes. These catastrophic events are rare, but leave a permanent mark on our planet and on human history. The science behind megaquakes. To understand these massive earthquakes, we need to start with plate tectonics. Earth's crust is made of several gigantic plates that float slowly over the semi-fluid mantle below. The edges of these plates, known as plate boundaries, are where most earthquakes occur. The most destructive quakes usually happen at subduction zones, where one tectonic plate dives beneath another. As the plates press together over decades or centuries, stress builds up. When the stress exceeds the strength of the rock, it's suddenly released in the form of seismic waves, producing an earthquake. The more energy stored, the stronger the quake. 1960 Valdivia earthquake, the biggest ever recorded. On May 22, 1960, Chile experienced the largest earthquake ever recorded, a staggering magnitude 9.5. It struck the region near Valdivia and caused massive destruction. The ground shook violently for more than 10 minutes, and entire towns were destroyed. The earthquake triggered a series of tsunamis that traveled across the Pacific Ocean, striking Hawaii, Japan, and even the Philippines. In total, between 1,600 and 2,000 people died, and millions were left homeless. This earthquake reshaped Chile's coastline, lowered some areas by several meters, and raised others. It also spurred global efforts to monitor tsunamis more effectively. 2004 Indian Ocean earthquake and tsunami. On December 26, 2004, the world witnessed one of the deadliest natural disasters in modern history. A massive magnitude 9.1 to 9.3 earthquake struck off the coast of Sumatra, Indonesia. The quake ruptured a section of the fault more than 1,300 kilometers long, displacing billions of tons of water and creating an enormous tsunami. Within hours, giant waves devastated coastlines in Indonesia, Thailand, Sri Lanka, India, and even reached as far as Somalia in East Africa. The disaster killed over 230,000 people and displaced millions. It also highlighted the urgent need for early warning systems, leading to the creation of the Indian Ocean Tsunami Warning and Mitigation System. 2011 Tohoku earthquake and tsunami. On March 11, 2011, Japan experienced a magnitude 9.0 earthquake off its northeast coast. It was one of the most studied earthquakes in history because of its impact on a modern, developed nation. The quake unleashed a tsunami that reached heights of 40 meters in some areas and traveled several kilometers inland, wiping out entire towns. Over 18,000 people were killed or went missing. The disaster also caused the Fukushima Daiichi nuclear plant meltdown, leading to a long-lasting environmental crisis. Japan's main island shifted by about 2.4 meters, and Earth's axis tilted slightly, shortening the length of a day by microseconds. 1964 Great Alaska Earthquake. On March 27, 1964, Alaska was struck by a magnitude 9.2 earthquake, the largest ever recorded in North America. It lasted for nearly 4.5 minutes and caused massive ground fissures, landslides, and tsunamis that reached as far as California. Although Alaska's population was relatively small, 131 people died, and many coastal communities were destroyed. This earthquake reshaped much of Alaska's landscape and provided scientists with key data about subduction zones and how they produce megathrust quakes. 1952 Kamchatka earthquake. On November 4, 1952, a magnitude 9.0 earthquake struck the Kamchatka Peninsula in Russia. While the region was sparsely populated and casualties were limited, it generated massive tsunamis that reached across the Pacific, damaging coastlines in Hawaii and other Pacific islands. This event was crucial for scientists, as it occurred during the early years of modern seismology and helped refine earthquake measurement techniques. 1700 Cascadia earthquake long before modern instruments on January 26, 1700. A magnitude 8.7 to 9.2 earthquake struck the Cascadia subduction zone off the Pacific Northwest coast of North America. We know about this quake through a combination of indigenous oral histories and Japanese historical records describing an orphan tsunami that struck Japan the same night, with no local quake. This discovery proved that the Pacific Northwest is capable of producing massive earthquakes and tsunamis, driving modern disaster planning in the region. 1868 Arica earthquake. On August 13, 1868, a powerful magnitude 8.5 to 9.0 earthquake struck near Arica, then part of Peru, now Chile. The resulting tsunami devastated coastal cities and reached as far as New Zealand. Tens of thousands of lives were lost. This event served as an early warning of the Pacific's vulnerability to distant tsunamis and encouraged further study of tectonic activity in South America. 2005 Nyasumulu earthquake. On March 28, 2005, just 3 months after the catastrophic 2004 disaster, another massive magnitude 8.6 earthquake struck near Nias Island, Indonesia. While the tsunami it produced was smaller, the quake still caused widespread destruction and killed more than 1,300 people. It highlighted the ongoing seismic risks in the region and the need for continuous monitoring and preparedness. Secondary hazards: tsunamis, landslides, and volcanoes. Mega earthquakes rarely occur alone. The sudden movement of land can trigger underwater landslides, volcanic eruptions, and most dangerously, tsunamis. Tsunamis are particularly deadly because they can strike thousands of kilometers away from the earthquake's epicenter. Traveling at speeds of up to 800 kilometers per hour, they can devastate coastal regions with little warning. Advances in monitoring and warning systems. The scientific community was compelled to research and construct worldwide seismic networks and tsunami warning systems as a result of historic disasters. Earthquakes may now be detected in a matter of seconds, and alerts can be sent to areas that are at risk, thereby saving a great number of lives. However, there is a limit to how far technology can go. At the local level, rapid response, education, and preparation continue to be essential for survival in the event of megaquakes. The human and economic cost. Not only can mega earthquakes result in immediate mortality, but they can also result in the displacement of millions of people and economic losses that can go into the hundreds of billions of dollars. For instance, the natural disaster that struck Japan in 2011 resulted in losses of more than $360 billion, making it the most expensive natural disaster in the history of the world. Construction of new infrastructure and the provision of assistance to those who have survived can frequently take years or even decades. Lessons for the future. Through the study of the greatest earthquakes in the world, scientists are able to have a better understanding of the locations where future megaquakes are likely to occur. Stress is still being accumulated in certain regions, such as the Cascadia subduction zone, the Himalayan belt, and certain sections of South America. And it is possible that this stress will eventually be released in the form of another large earthquake. Being well prepared, which includes having stringent construction rules, conducting emergency exercises, and educating the general public, is our best protection against the unavoidable.